name is Idehen. This class is brought to you by Isaac Humanitarian Foundation. So we are still dealing with mathematics, and the topic is about special angles, compound angles, and negative angles. These angles, when we say special angles, what do we mean? These are the angles that we can get without the use of calculator. Special angles. Why are they special? Because we can derive them, we can derive the value from what? From shapes, most plane shapes. So let us look at them briefly and take some examples. So when we say special angle, there are some special angles. There are some angles that are special compared to other angles whatsoever. Angles can be anything from what? 1 to whatever number. But from here, a special angle, we are having what? 30 degrees, 45 degrees, 60 degrees. 30, 45, and 60 degrees. That's what we consider as special angles. In some other people may call it other names, but I call it special angles. Special angles. So, briefly, okay, we have an equilateral triangle. Equilateral triangle. Equilateral triangle. From this triangle, we can derive some of our special angles here. Can derive some of our special angles. So here, in an equilateral triangle, all the sides and angles are equal. Meaning that this angle here is 60 degrees, 60 degrees, and what? 60 degrees. All the sides and all the angles are equal. So from here, I want to derive the trigonometrical ratio for what? 60, 30, and 45. So how do we do this? I bisect this triangle into two. So this bisector calls this angle into two. So if you call the angle into two, we have 30 degrees and 30 degrees respectively, making 60. So from here, since this is a perpendicular line to the line here, let's assume this A, B, and C. Since this is a perpendicular line, so this one cuts, this line cuts this angle into 2, 30, 30, while the angle here will be what? 90, since it's a perpendicular. So we have taken one of the what? Right angle triangle. Taking one of the right angle triangle. Let's call it A, this is still B, this is still C, and this one is, let's call it O. Then from here, we say this is 60 degrees, and this one is 30, this is 90, right angle triangle. So we can assume this is 2, this is 2, and this is 2. Whatever value you put there is the same thing. So I am assuming that all the sides are what? 2. So if all the sides are 2, mean that this is also 2. But this side here that I've divided into 2 will be what? 1. So here we have 1, 1, making 2. This one remains 2. So we have only one part of the what? Equilateral triangle. So I'm using this to derive angle 60 and angle 30. So here, from our trigonometrical function, we say what? Sine theta is equals to opposite over what? Hypotenuse. So cos theta equals to adjacent over hypotenuse, and tan theta is equals to what? Opposite over what? Adjacent. So I will take the sine of each angle, the sine, cos, and tan of each angle, and we'll see what we get or what we derive. So I'm taking for 6, let's take for 30, sine 30. But before that, Before that, we have to determine the what? The perpendicular line. So we have to determine this line, let's call it x. Since this one is a right angle triangle, we have to adopt the Pythagoras theorem to find that side of the right angle triangle. So from here, the Pythagoras theorem states that what? The square of the hypotenuse side, that is what? 2 square, is equal to the sum of the squares of the other two sides. That is 1 square plus what? S square. 2 square is what? 4. And 1 square is what? 1 plus what? S square. So we are finding what? X. We are solving for S. You see, therefore, our S square is equals to, when 1 comes here, we have 3. So our S is equals to what? Square root of 3. S is equals to square root of 3. So you can replace it. S square root of 3. And this one is 1, 2, 30 degrees. And what? 60 degrees. So from here, I'm taking sine 30. Sine 30, it says sine is what? Opposite of hypotenuse. Opposite 1, hypotenuse 2. So sine 30 equals to what? 1 over 2. Cos 30. Cos 30 is equals to what? Adjacent over hypotenuse. The adjacent side is the third side. Opposite side is the side facing an angle, while the hypotenuse is the largest side of the right angle triangle. So we are looking at angle 30. So the opposite side is 1. The hypotenuse side is what? 2. While the adjacent side is what? Root 3. So from here, sine 30 is what? Adjacent over hypotenuse. Adjacent is what? Root 3. Hypotenuse is what? 2. So sine 30 is root 3 over 2. And then tan 30. Tan 30 is what? From here we have tan 30. Opposite over what? Adjacent. 1 over root 3. Using your sword, we have root 3 over 3. That is that. Then we come towards 60. Sine 60 is equals to, sine 60 is what? Opposite over what? Hypotenuse. Root 3 over 2. Cos 60. Cos 60 degrees equals to what? Adjacent over hypotenuse, 1 over 2. And tan 60 equals to what? Opposite over what? Adjacent. Root 3 tan 60, opposite over adjacent. Root 3 over 1. Root 3 over 1, which is equals to what? Root 3. So this we can determine all the what? Angle, all the three functions for what? Sine for what? 30 degrees and 60 degrees. That's why we call them what? Special angles, because we can determine them without what? The use of calculator. Then again, let us do for what? 45. So to get 45, we are going to use what? A square. Using a square to determine the three functions for what? 45 degrees. So a square, now I'm taking 1, 1, 1, 1. A square, all the sides are equal and all angles are equal. So here is what? 45. 90, 90, 90, and what? 90. The same way, I draw a diagonal to cut the square into 2. So I'm taking the lower part. I'm taking the lower part. So here I'm having 1, 1. That's the what? The right angle. So for this one, I have what? Root 2. Using Pythagoras theorem. 1 square plus 1 square equals to what? This square. So I have root 2. So then, this is 90. So I've divided this one into 2, making this place 45 degrees and 45 degrees. The same thing here. 45 degrees, 45 degrees. So here is 45 and here is 45. By the time you add all the three, it will sum up to 180, sum of angles in a triangle. So from here we can adopt the trigonometrical function. Sine 45 degrees then is equals to what? Opposite to adjacent, whichever angle you are referring to here is the same. Because the opposite of this is 1, opposite of this is 1. So sine 45 is what? Opposite over what? Hypotenuse. Opposite over hypotenuse. Follow me. So opposite of this is what? 1. Hypotenuse is what? Root 2. By using solve, you get what? Root 2 over 2. Cos 45 degrees. The same thing, cos 45. So we have what? Adjacent over hypotenuse. Adjacent of this 45 is this one, and the hypotenuse is what? Root 2. 1 over root 2. By using solve, you get the same thing, root 2 over 2. And then tan 45 degrees is equals to tan is what? Opposite over adjacent. Opposite over what? Adjacent. So we have 1 over 1, which is equals to what? 1. So this is invariably telling us that what? Whenever you are given tan 45, you should know you arrive at what? 1. Whenever you are given cos 45, you get this. Sine 45, you get this. So from here, we can denote that sine 45 degrees is equals to cos 45 degrees, which is equals to what? Root 2 over 2. The same thing here. 1 sine 30 is equals to what? Cos 60. And sine 60 is equals to what? Cos 30. Note, sine 30 equals to what? Cos 60 degrees, which is equals to what? 1 over 2. And sine 60 is equals to what? Cos 30, which is equals to what? Root 3 over 2. We have that. These are all the special cases in what? Angles. 30, 45, and 60. Then we can move to compound angles. Compound angles are just telling us about what? Compound angles is telling about it's talking about combining 2 or more special angles. We are combining 2 or more special angles. Combining 2 or more special angles. We have what? Compound angle, whether it was addition or subtraction. But before that, we have angle 0, 90, 180, 270, and 360, which you can also determine the same way as what? Our special angles. So now we want to determine this using our sine graph, cosine graph, and what the tangent. From here, our sine graph is thus. Here we have 1. Here we have minus 1. So from here we have 0, 90, 180, 270, and 360. This is the x-axis, and we have the y-axis. So this is what the sine function. This is what y equals to sine theta. Y equals to sine theta or sine what? X, whichever. Y is equals to sine theta. So from here, you can say, therefore, sine 0. Sine 0 degree is what? Where our x, where our theta is equals to 0. Sorry, since this one is x, then this one will be x. Y equals to sine x. So sine 0 is where our x is equals to 0. X is equals to 0 and they meet at the origin. So mean that sine 0 is equals to what? 0. Where the x-axis meets the what? The curve. The x-axis meet this curve at point what? Point 0. Then again I have 90. Sine 90 degrees is equals to where the x-axis meets 90. Where do we meet? This 90. So I'm tracing this up. We meet here, then what is y at that point? Y is equals to what? 1. Y is 1. So mean that sine 90, when s is equals to 90, then y is equals to what? 1. From this equation. Then again we have 180, sine 180. When s is equals to 180 and s equals to 180, what is y? Y is what? 0. Having the points 270 sine 270. When s is equals to 270, what is y? Y is equals to what? Minus 1. And then the last one, sine 360. When s equals to 360, y is still what? 0. Y is equals to 0. So from here we have determined the value of both sine y, sine 90, 180, 270, and 360. In the same way, we can have that of cosine. We can have that of cosine. You have cosine. So my y-axis, and this is the s-axis. Cosine function comes this way. That's this. So from here, this one is 1, and this is what? Minus 1. This is the origin 0. So we have 0, 90, 180. 270 and what? 360. This one is y equals to what? Cos s. So from here, the same way we can determine the value of 0 and all these other angles. So cos 0 degree is equals to what? This is where s is equals to 0. When s is equals to 0, what is y? Y equals to what? 1. So cos 0 is 1. The same way, cos 90. Cos 90. So when s is equals to 90, what is y? Y is what? 0. Cos 90 is what? 0. Y is 0 when s equals to what? 90. Then 180. Cos 180. When s is equals to 180, what is y? Y is equals to what? Minus 1. Cos 270. Cos 270. When s is equals to 270, y is equals to what? 0. And cos 360. When s equals to 360, y is equals to what? 1. So we have 1. That's what we have under sine and cosine. And tangent is just what? Sine divided by what? Cosine. So whenever you are getting your tan of what? 0, 90, 180, 270, and 360 from your trigonometrical identities, which they've treated under in some videos, we said what? Our tan theta is equal to what? Sine theta over cos theta. So from there, when you impute all the value of sine and cos for what? 0, 90, 180 and this, you get what? The value of what? Tan 0, 180, 180, 270 and 360. Tan 0 then will be what? Tan 0 will be what? Sine 0 over what? Cos 0. Sine 0 is what? 0. Cos 0 is what? 1. So this one will be what? 0. The same way, tan 90 will be equals to what? Sine 90. Sine 90 over what? Cos 90. Sine 90 is what? 1. And cos 90 is what? 0. This one is what? Indefinite, undefined. So we have undefined. But now, is it positive or negative? It is what? Positive infinity. Then for what? 270 times 270 is equals to sine 270 over what? Cos 270. So this one then is what? Sine 270 is what? 0. Cos 270 is what? Sine 270 minus 1. Cos 270 is what? 0. This one now is what? Negative infinity. Different from this. The same thing but for different sign. So we have what? Negative infinity. And then tan 360 is equals to what? Sine 360 over what? Cos 360. Which is equals to what? 0 over what? 1. Which is equals to what? 0. So that's what we have under what? Special angles and compound angles. Then negative angles, I'm just talking about normally on our coordinates. On our coordinates, we have 4 quadrants. We have 4 quadrants on the coordinates. So how do we determine the value? We just have to what? Remove the negative angle from what? 360 degrees. Remove the negative angle from what? 360 degrees. Negative angles. Negative angles. These are quadrants. The first quadrant, second, third, fourth. So normally our angle will move what? In an anti-clockwise direction. Positive angle will move in an anti-clockwise direction, while negative angle will move what? In a clockwise direction. Clockwise direction. Anti-clockwise, clockwise. So this one is what? Negative. Negative. Clockwise direction. This one is what? Positive. Positive. So whenever we are given a negative angle, we just remove it from what? 360. Why? So we are going to find what? Give an example. Find angle, find sine minus 270. Sine minus 270. To get this, we are not coming this way because this is what? For positive angle. Why this is for negative angle? To get this on the coordinate, sine 270 will now start from here. Negative sine minus 270, 90, 180. So let me make it 250. 90, 180. Then 250 will be here. This is a negative angle. Minus 250. So from here now, I can determine this angle by complementing it. I'll merely complement it here with what? A positive angle. So how do I complement this? So what is the positive angle here? It's just removing this 250 from what? 360. So therefore, sine minus 250 is equals to sine 360 minus what? 250. This one then gives me equals to what? Sine 360 minus 250 give me what? 110. 110. So you can then find your sine 110. Whatever you get here will be the same thing as what? Sine minus 250. So if you use your calculator, sine minus 250, sine minus 250 is equals to 0.939. So I gives us what? 0.9396. Then sine 110. Sine 110 is equals to the same value, 0.9396. So basically, when you are given a negative angle and you have to find the sine or the trig of a negative angle, just simply remove that angle from what? 360 degrees and find the what? The angle. So whether you can use your special angles to solve it or not, or your compound angle whatsoever, just remove your 360, just remove the value from 360 degrees, then you have what? Get a complementary angle, and that angle will be equal to what? The same, and it will be the same thing as what the negative angle. So that is that. Thank you.